Video is on integration using residues. In today's video, we are going to determine the poles and the residues of the given function f of z is equal to z square by z plus 2 into z minus 1 square. See here, first of all, what is f of z given? So f of z is given as z square by, this is z plus 2 into z minus 1 square. First, I have to find the poles for the given function. So in order to find the poles, so we have to equate the denominator to 0. So what is the denominator here? The denominator is nothing but z plus 2 into this is z minus 1 square to 0. So if I equate z plus 2 to 0, so we got z is equal to minus 2. So which is a simple pole. So this is a simple pole. So this is z is equal to 0 if I equate. So which is also a simple pole. So if I equate z minus 1 square to 0, so I got the value of z is equal to 1 for 2 times, which is a pole of order 2. Pole of order 2. So we got the pole values. So the first pole value is z is equal to minus 2 and z is equal to 0 and z is equal to plus 1. See, we have to determine the poles. So in order to find the pole values, we have to equate the denominator to 0, and after equating we got 3 poles as z is equal to minus 2, z is equal to 0 as simple poles, and z is equal to 1 is a pole of order 2. And next one, what we have to find? So we have to find the residues for the given function for the corresponding pole values. So residues I am finding. So for finding the residues, first the formula here is the residue of f of z at z is equal to z naught. So this is the formula I am writing. So this is nothing but 1 by m minus 1 factorial into limit z tends to z naught. Clear? This will be d by dz power, this is m minus 1 into this value is z minus z naught power m into f of z. So in this, for the residue z is equal to 1, for z is equal to 1 I am finding. So this will be, if I keep z naught as 1, the pole value z naught as 1, and the order value, see here it is of order 2, order value as 2, and see if I substitute, I will be getting the residue value of the function f of z, residue value of the function f of z at point z is equal to 1. So this will be 2 minus 1. So this is 2 minus 1 factorial into limit z tends to 1. This will be d by dz times of, this is 2 minus 1 and this is 2 minus 1. This is z minus z naught value is 1 par m. M value is a square into f of z. So what is our f of z value? So f of z is nothing but this is z square by z plus 2 into z into again z minus 1 square. Clear? So now I have substituted f of z value. Now I'll cancel these two, z minus 1 square and z minus 1 square. So this will be 1 by 2 minus 1 factorial is nothing but 1 factorial. So I'm leaving this one. So limit z tends to 1. This is d by dz times of. So what is the function left? Z square by this value is z plus 2 into z. Now if I send this z, multiply with the denominator, then this will be limit z tends to 1 d by dz times of, this is z square by, this is z square plus 2z. Now we have to make a derivative. So which is of the form u by v rule. So this is u and this value is v. So for u by v, the derivative is nothing but this is v square v u dash minus u v dash. Clearly we have to write v for twice. We have to leave v, we have to make a derivative for u, and again we have to leave u and we have to make a derivative for v. So that's what I'm doing here. So this will be limit z tends to 1. Here v square, that is z square plus 2z square. So this is v square, and we have to write v for one time, that is z square plus 2z, and we have to make a derivative for u. So what is the derivative for u? This is 2z, and again we have to leave u, so I'm leaving u as it is, z square, and I have to make a derivative for v. So v, it is nothing but 2z plus 2, and in this I have to substitute z value as 1. So if I keep z as 1, so this will be 1 plus 2, and again z value as 1, so 2 remains, and this is a z square is 1, and this is 2 plus 2, that is 4, by this is 1 plus 2 square. So this value 3 2s are 6. So this value is a 6 minus 4 by 3 square, which is equal to 9. So the value here is 2 by 9. Therefore, the residue of f of z at point z is equal to 1 is nothing but 2 by 9. So 2 by 9 is the residue value after substituting in the formula. So here, so this is the residue value. And next thing here is this was done, and we have to find the residue for z is equal to 0. So in order to find the residue at point z is equal to 0, see, residue of the function f of z at point z is equal to 0. As it is a simple pole, the limit also, limit z tends to, this is z naught. So this is z minus z naught into f of z is the formula. So in this, if I substitute, then this will be residue of, this is residue of f of z at point z is equal to 0 is nothing but limit z tends to 0. This is z minus 0 into the function value. So what is the function value here? The function value is nothing but this is z square into this is z plus 2 into z into this is z minus 1 square. So if I cancel the single z here and substitute 0 value, so this will be 0 by 0 plus 2 into 0 minus 1 square. 0 by anything, the value here is 0. And therefore, we got the residue of the function f of z at point z is equal to 0 as 0. The residue value at point z is equal to 0 is 0. And the next pole value here is, so for 0 it is done, and for z is equal to minus 2. For z is equal to minus 2, the residue value is nothing but residue of f of z at point z is equal to minus 2 is nothing but the formula here is limit z tends to z naught. This is z minus z naught into this is f of z, and therefore this value is equal to limit z tends to minus 2, this is z plus 2 into f of z. F of z is nothing but z square by this is z plus 2 into z minus 1 square. Z plus 2 got cancelled, and if I substitute z value as minus 2 square, this is minus 2 into minus 2 minus 1 square. So the value here will be 4 by minus 2 into this value is 9. So if I cancel for 2 times, this is minus 2 by 9. So the residue value of f of z at point z is equal to minus 2 is minus 2 by 9. So this is the residue value. So first thing what we have done is we have to determine the poles as well as the residues for the following function: z square by z plus 2 into z minus 1 whole square. In order to find the poles, we have equated the denominator to 0, and we got the three poles: z is equal to minus 2, z is equal to 0, and z is equal to 1. So this is the pole of order 2. So we have to substitute in this formula as m is equal to 2 and z naught is equal to 1. So after substituting and making a derivative for one time and substituting z value as 1, so we got the value, first pole value is 2 by 9, and the next one is z is equal to 0. It is a simple pole, and therefore z minus 0 is cancelled, and we have to substitute z is equal to 0 in the rest of the function. So again it is 0, and z is equal to minus 2 is also a simple pole. We have to cancel z minus 2 in the numerator as well as denominator, and we have to again substitute z value as minus 2, and we got the residue value as minus 2 by 9. So this is how we have to solve. These problems are the most important problems, repeatedly asked questions, and definitely you can solve by your own if you follow these videos. And if you really like what to do, please subscribe and pass it on to your friends.